Okay, when we last saw tables, we only knew tables as finding k, which when we found k, it was always k equals y over x. Like all we did was divide y divided by x. But we're going to see today where that doesn't always apply. For instance, I'm going to show you two examples on the tables and why it's going to be different this time. So for instance, if I look at this table on the left, to be proportional is when k equals y over x. And what I mean by that, like the ratio k is constant. Like if I look at this example, x is on the top, y is on the bottom here. So I have to incorporate y over x, which 0 over 0 doesn't apply because that's known as the origin. But if I look at the next one, if I do 5 over 1, and then 10 over 2, and 15 over 3, and 20 over 4, notice what all of those would simplify to. 5 divided by 1 is 5, 10 divided by 2 is 5, 15 divided by 3 is 5, and 20 divided by 4 is 5. So k would equal 5, and then remember we wrote it as an equation, y equals 5x, like that's great. But what you're going to notice now from this part of chapter 5 is it's not always going to be that way. For instance, if I look at this table right here, I would do 9 over 0, 11 over 1, 13 over 2, and 15 over 3. When I divide all of those out, 9 over 0, of course, wouldn't apply, but 11 over 1 is 11. 13 over 2, when I divide that out, I would get like 6.5. 15 over 3 would be 5. And notice that it's never the same. And when we learned that in chapter 5, we didn't do anything with it. But today, that's where it's going to be different. So the ratio of k is not constant here. And that just means that it's not going to go through the origin. It's going to go through, it's not going to go through the origin. It's going to go through another point on the graph. So how do we do this whenever it doesn't? Well, this is where we're going to do something a little different. We are going to look at the pattern. And what I mean by pattern is I look at what happens from 9 to 11, 11 to 3, and 3 to 5. Did you notice a pattern as I was counting? From 9 to 11, that's plus 2. From 11 to 13, that's also plus 2. From 13 to 15, that's also plus 2. But I not only do that for my y's, I'm going to do it for my x's as well. So 0 to 1 would be plus 1, 1 to 2 would be plus 1, and 2 to 3 would be plus 1. Now, we are still essentially doing y over x, but it's not just the y over the x, it's the change in y over the change in x. So what was I changing the y's by? I was changing the y's by 2. And then what was I changing the x's by? I was changing the x's by 1. So they all have a pattern of 2 over 1, which simplifies to 2. And so it's no longer k, it's something referred to as m, the slope, which we found the last couple of days, and m equals 2 this time. Now, what's also different about it is it doesn't cross through the origin. And I know it doesn't cross through the origin because of the 9 over 0, 11 over 1, 13 over 2. It wasn't constant. So to find what the y-intercept actually is, I look at the table to see where x is 0. Notice this first one right here. The x is 0, but my y is 9. That's where it's crossing the y-axis at positive 9. And if I lost you, that's okay, because we're just gonna practice it. So let's look at number 1. Well, here's my table. Okay, now if I did the y over x, 5 over 1, 8 over 2, 11 over 3, 14 over 4, they would never be consistent or constant. So what we're gonna do is look for a pattern instead. So if I look at my x's, notice from 0 to 1, 1 to 2, 2 to 3, 3 to 4, I'm adding 1 every single time. Versus on the right side, on the y's, from 2 to 5, 5 to 8, 8 to 11, 11 to 14, I'm adding 3 every single time. So I'm still doing y over x, but it's change in y over change in x. How are my y's changing? I'm adding 3. How are my x's changing? I'm adding 1. So it's 3 over 1, which equals 3. Now, the y-intercept is going to be the trickiest part about this chapter because I have to look at my table and see where the x is 0. Well, do you see where x is 0 anywhere? On that very first position. And 0, 2 means that the y-intercept is 2. like we've been doing on the graphs. So my equation is y equals my slope, which is 3x, and then my y-intercept is positive 2, so I have to remember to put plus 2, and that's it. If I lost you, let's do that again. So where it gets a little messy is when negatives are involved. So I have to look at my pattern. Notice from -4 to -3, from -3 to -2, from -1 to -2 to -1, and from -1 to 0. It looks like I'm subtracting 1, but I'm actually adding 1 because my negatives are going closer to 0. Not subtracting 1, but adding 1. If I look at the y side, 6 to 8, 8 to 10, 10 to 12, 12 to 14, I'm adding 2 every single time. So again, for slope, we're going to do y over x, but it's 2 over 1, and that would just be equal to 2. Now, look at your table. Is there anywhere where the 0 or x is 0? If you look at it, x is 0 at 0, 14, so my y-intercept is 14. So my equation would be y equals my slope, which is 2x. My y-intercept is positive 14, so I have to remember to put plus 14. Not too bad. Let's do the hardest one. The hardest one is when there's negatives everywhere. So let's look at the pattern. From -3 to -2, -2 to -1, from -1 to 0, from 0 to 1. I am not subtracting 1, I'm adding 1 every time. And then on the y side, -6 to -7 to -6, -6 to -5, from -5 to -4, from -4 to -3. I'm not subtracting 1, I'm adding 1 because my negatives are getting smaller, which means addition. It's really backwards when it comes to negatives. But my change in y over my change in x is 1 over 1, which just simplifies to 1. Now, my y-intercept, where in the table do you see x is 0? Well, right here is where x is 0. So this time my y-intercept is -4. And so my equation would be y equals 1x. And since it's -4 this time, it would be -4. Okay, I'm going to jump. Something we haven't really practiced with is whenever a table is sideways or horizontal, if you will. So you just have to remember that your x's are on the top of the table versus your y's being on the bottom versus left and right. Okay, same idea. Now, if I look at number 4, same thing. We're going to look for a pattern. So if I look at my x's and I go from left to right, it's going to go 0 to 4, 4 to 8, 8 to 12, and 12 to 16. Did you notice what's happening? It's adding 4 every single time. Versus the y values, notice from 3 to 6, 6 to 9, 9 to 12, and 12 to 15, it's adding 3 every single time. Now the thing you have to remember with these is it's always rise over run, which is y over x. So my y is 3, positive 3, and my x is positive 4. Now is there anything I can do to simplify 3 over 4? I can't. And so it's just 3 over 4. My y-intercept, again, we look at the table to where x is 0. Well, this time x is on the top, and notice 0 is right there. So if my x is 0, my y-intercept is positive 3. And now we just mesh it together and make our equation. Y equals 3 over 4x. And since it's positive 3 as my y-intercept, we're just going to put plus 3. Now, let's talk about worst case scenario. Let's say the pattern's the same. So look at number 5. Where I look at my pattern for my x's, 2 to 4, 4 to 6, 6 to 8, and we're adding 2 every single time. Versus my y's, -5 to -6, -6 to -7, -7 to -8. It looks like we're adding, remember, but since it's negatives, we're subtracting 1 because my negatives are getting larger. I do y over x, so this time it's -1 over 2, and I can't simplify -1 over 2. A lot of people think it's 2. It is not. But notice that my y-intercept is a little tougher here because it does not have x as 0. So this is one of the cases, and hopefully you don't see one this difficult, where I have to go find 0 myself. Well, and I have to look for where x is 0, which means I have to go backwards from adding 2 to subtracting 2 to get to 0. And so 2 minus 2 is 0. Well, if I have to go backwards once to get to 0 here, I have to go backwards once here to get to that same position. So instead of subtracting 1, we're going to add 1, and -4 plus 1, or sorry, -5 plus 1 is -4. So I had to go find my y-intercept myself. So that's the trickiest part about these. And now I have it. It's -4. So my equation is y equals -1/2 x. And since it's -4, we put -4. And that's it. But let's do that again. Number 6, we still look for a pattern. So from -5 to -10, -10 to -15, -15 to -20, and -20 to -25. My negatives are getting larger, so we're subtracting 5. Even though larger, yes, normally means addition, it's subtracting 5. My y's are going -8 to -16, -16 to -24, 24 to 32, and 32 to 40. I'm going by 8, but since we're getting negatives, my negatives are getting larger, it's -8. Again, that's a little topsy-turvy there, but there it is. Now, we still do y over x. This time it's -8 over -5. And a negative over a negative is a positive. And I can't simplify 8 over 5, so it's just 8 over 5. Now, to find my y-intercept, I have to look for where x is 0. Well, 0 is not on the table, so I have to go backwards to find 0. Well, if we were subtracting 5 going to the right, I'm going to add 5 going to the left, and -5 plus 5 is 0. So I only had to go back once. Here, I'm subtracting 8, so the opposite would be to add 8, and I only have to go backwards once because that's how long it took me to get to 0. So -8 plus 8 is also 0. So my y-intercept in this case is 0, and we talked about that last week. Y equals my slope, which is 8 over 5x. And when I have a y-intercept of 0, we do not put anything after x. So let's practice a few more. Number 7. Again, I do my table. So 2 to 3, 3 to 4, 4 to 5. My x is adding 1. My temperatures on the right side, my y's, would be 60 to 63. I'm sorry, this is not a consistent temperature. So I'm not going to use number 7. We'll skip it. All right, number 8. So if I go from -6 to -5, -5 to -4, -4 to -3, and -3 to -2, my negatives are getting smaller, so I'm adding 1. Again, it's backwards, I know. My y's are going from -4 to -9, -9 to -14, -14 to -19, -19 to -24. I am going bigger negatives, which means I'm actually subtracting, and then I'm subtracting by 5. So my y over x would be -5 over +1, and a negative divided by negative is a negative, and then 5 over 1 is just 5. If it was 1 over 5, it would be 1/5. Now my y-intercept. So this is a little dicey here because my 0 would not be above -6, it would be below -2. So I would have to go from -2 to 0 somehow. Well, if I'm jumping by adding 1, I have to add 1, which would be -1, and then add 1 again, which would be 0. So I have to go 2 times to find 0, which means I need to go 2 times on the y side. Well, -24 minus 5 is -29, and -29 minus 5 is -34. So a hard one, I know, but my y-intercept is -34. So y equals, let's see if I can find it. Y equals my slope, which is -5x, and then my y-intercept, which is -34. Again, this is the hardest it can be, but hopefully you have one where the 0 is on the table. If I look at the next one, 7 to 6, 6 to 5, 5 to 4, 4 to 3, I'm subtracting 1 every single time, versus my y's, 4 to 6, 6 to 8, 8 to 10, 10 to 12, I'm adding 2 every time. So my slope would be rise over run, or y over x, so 2 over -1. Positive over a negative is a negative, and 2 over 1 is just 2. Now, to find my y-intercept, I need to look for where x is 0. Well, I can't go to the left of 7 because I'm getting bigger. I have to go to the right of 3. Well, if I'm subtracting 1 every time, 3 minus 1 is 2, 2 minus 1 is 1, and 1 minus 1 is 0. So how many jumps did it take me to get to 3 to 0? It took me 1, 2, 3 jumps, which means I need to go 3 jumps to get to that same position on the y, which means adding 2 3 times. 12 plus 2 is 14, 14 plus 2 is 16, and 16 plus 2 is 18. So my y-intercept ends up being positive 18. Again, I know, tough. So y equals negative 2x, and since it's positive 18, I put plus 18. But hopefully when it comes to 7th grade, you see where the 0 is in the table, so you don't have to go find it yourself.